Right, my name is Pierre Sutherland. I'll be the teaching assistant for EMAT 7080 with Dr. Steffi. I'm going to show you the basic functionality of Geometer Sketchpad and a quick construction just to give you some overview of how this technology works. So I'm going to search for GSP. I recommend that you buy the student license instead of just getting a year license. For me, I think it's cheaper than a textbook, and you'll use it more often, I think, once you're done with the course as well. This is what your interface is going to look like. And here on the left hand side you have the tools that you'll probably be making the use of the most. For instance, if I want to make a point, I can plot a point there. Here we have a circle. The circle is defined by these 2 points. A line, you've got 3 different kinds. The first one would be a segment. A segment runs from one point and terminates at another. A ray would start at one point and not terminate. And of course a line would run infinitely through 2 points. And if I want to manipulate these objects, I just need to move the points that define them. If I move this point, I can manipulate the radius. If I move this point, I can move the circle. Same with the segment. This allows me to rotate the segment, and it'll be the same for the ray and also for the line. I'm going to set up a new page here. File, document options. Remember, you can pause at any time to try this for yourself on your GSP as well. Document options, add page, blank page. I'm going to construct a square, and intuitively you might think that if I want to make a square, I can use a segment and then use another segment, one more, and finally close it up, and that would be a square. But in this case, with GSP, this would be a bad construction of a square, because when I manipulate these points, the square would lose its properties. This is no longer a square. This kind of looks like one, but this is not one. So this is not the good construction of a square. GSP assigns rules to the segments, to the lines and the circles that you construct. So if you want to draw something, construct something like a square, you could use a line. Usually it's a better idea to use a line than just a segment. I'm going to draw a line here, and I'm going to define my square by a segment that is, I'm going to make it the same length. It doesn't have to be, it could be this length. I'm going to Control Z to undo that, and I'm going to define it to be the length of these 2 points. Right, so there's my segment, and it automatically dashed this line. You can undo that in appearance settings under display, and you could say line style. I prefer a solid line instead of the dashed line that I have now, or you can make the thickness thin, medium, or thick. Right, I'm going to hide this line because I don't want to see that right now, so I'm going to say display, hide line. In the future I'm going to be using Control H. Right, now I want a circle, and I know that the sides of a circle, the side that runs here, must be perpendicular to this segment, and a perpendicular line would need at least 2 things. You'd need a point through which it must run, and a line to which it must be perpendicular. So I've selected the point and the line, and now I say construct perpendicular line. And there I have it. And this line, I want the same. I'm going to select a point through which it must run, and the line to which it must be perpendicular. I'm going to say construct perpendicular line. Now there are many different ways which we can transfer this measurement, which is important to the square. To transfer this length onto this line. What I like, a nice classic method, is just to use a circle, because the circle will transfer. See, I'm defining the circle in terms of these 2 points. Right. And now I want this point, and I'm going to get it simply by clicking on it. That's an important point. And now I'm going to make a line that is, it can be either parallel or perpendicular to this line, or it can be parallel to this line. Let's go for parallelity. There we go, parallelism. Now we've got a parallel line. To finish off the construction nicely, I'm just going to use some segments, and I'm going to hide everything that I don't need. There's my 3rd segment and my 4th segment. Right, and now I select and hide. Select, oh, that's the wrong button, and Control H, and there you go, you've got a square. Now this square I can move around. If I use this point, manipulates the position. This point, same position, and this point allows me to rotate the square, and it maintains its properties. The reason for this, I'm going to unhide everything I've done, show all hidden objects, is that everything is still there. And the reason I was able to manipulate the length of the side is because it was defined by this segment. And now if I manipulate this segment, then the whole square has to obey that new length. The rule is that that length must be the same for all the sides. So that's what's going on behind the scenes. Now I have to hide everything again, and there you've got the construction of a square. So another exercise might be, how would you construct a rhombus or a parallelogram? So try that and let me know how that works. And yeah, that's the end of the first session. Thank you.